Layer 2 topologies have an automatic loop prevention mechanism with spanning tree protocol, but it makes some of your links not usable unless there's a topology change. Good thing there's Etherchannel, which is used to bundle multiple links to increase bandwidth and enable load balancing across links. By the end of this video, you will be able to understand what is Etherchannel, Etherchannel negotiation protocols, and Etherchannel configuration requirements. But that's not all. We'll also discuss its use cases, so stay tuned till the end of this video. Etherchannel is the technology for bundling multiple physical links into one logical channel called port channel. It adds up the bandwidth of the links that are bundled and enables load balancing. Meaning if there are 4 1G links, the bandwidth will be 4G. If in case one link fails, traffic will automatically fail over to other available links. Typically, you can bundle up to 8 links to form one port channel, but this varies depending on the device that you use. You can also configure port channel as a layer 2 or layer 3 interface. There are 2 negotiation protocols used between devices for Etherchannel: Link Aggregation Control Protocol or LACP and Port Aggregation Protocol, also known as PAgP. First is LACP, Link Aggregation Control Protocol. It's open standard under IEEE standard 802.3ad. It has 2 modes. One is active when port actively initiates LACP negotiation, and another one is passive when port responds to LACP negotiation but doesn't initiate. The other negotiation protocol is Port Aggregation Protocol, also known as PAgP. It's Cisco proprietary. It's only used on Cisco devices. It has 2 modes. One is auto, when port responds to PAgP negotiation, and another one is desirable, when port actively initiates PAgP negotiation. Here are combinations of configuration between devices to form Etherchannel. For LACP, active mode is used to initiate negotiation, and its equivalent in PAgP is desirable mode. You will also see another mode called on, which is used to form a channel without PAgP and LACP. Etherchannel has configuration requirements for it to form port channel. You need to ensure that these parameters are the same for all ports. Speed and duplex. All physical interfaces must have identical speed and duplex settings. Full duplex is used by default on most interfaces. Switch port mode. Switch ports must be configured consistently as either all access or trunk ports. VLAN configuration. For trunks, all ports must have the same native and allowed VLAN ranges. For access ports, you need to ensure that they are in the same VLAN. Protocol consistency. Interfaces must use the same negotiation protocol, LACP or PAgP, or be set to static on mode. Layer 2 or Layer 3. You cannot mix Layer 2 and Layer 3 interfaces within the same Etherchannel. All of them should be configured as Layer 2 or all Layer 3 interfaces. Here is a capture of a working configuration. You will see that interfaces have the same parameters. By default, interfaces are set to full duplex and they have the same speed. Both are set to Layer 2 trunk ports and with the same allowed VLANs. LACP was used to bundle interfaces. The simplest use case for Etherchannel is for bundling multiple links between 2 switches and provide redundancy. But technologies like stack switches and multi-chassis link aggregation provides another level of redundancy by bundling links between multiple switches. Stack switches are treated as one logical switch, so you would just need to identify one port for each of the member switch that will form the channel to the other device. Multi-chassis link aggregation also enables 2 switches to act as one logical switch, but instead of using stacked cables, it's done on switch ports with keep-alives and other configuration parameters. These technologies provide seamless failover in case one device fails in the network. That's it for Etherchannel. Etherchannel together with STP covers most of the redundancy in Layer 2 networks. But what if you need to connect to different subnets? This is where default gateway redundancy comes in. Default gateway serves as the first hop in Layer 3 connectivity and HSRP is used in Cisco devices for first hop redundancy. If you want to learn more about HSRP, check out this video. Thanks for watching and I'll see you in the next one.